our first presentation, which is Digitalization will make the semiconductor industry stronger. Our speaker, Chong Chan Pin, EVP and GM for Product and Solutions from Kulicke Soffa Pte Ltd, will talk about the need for companies to continue driving I 4.0 so that they will remain resilient towards impact from disruptions. So Chan Pin, over to you.
Hey, thank you, Gillian, for the introduction. Let me open up my presentation. Okay, so today's my topic will be called digitalization and how does it make semiconductor industry stronger, right? And of course, we know that through this whole period of COVID, we can see how things have transformed, right? So I'm going to show you a video of basically our Industry 4.0 or our digitalization in the semiconductor. I'll first introduce what's digitalization. If you can see from the video, right, there's a lot about automation. There's a lot about information. There's a lot about connectivity. It's a lot about support, right? Why is this industry so evolving so quickly? It's because of this amount of information that's being transferred and interoperate between each other, right? So when machines start to communicate with each other, you start to see things moving, and with this information, you can start to use this to do process control, simulations, okay, assistant support, and finally, decide, right, decision making, right? And we all hope that someday we could reach towards an autonomous decision making where machines can make decisions for us so that we don't have to manually enter a lot of information to make those decisions, right? So that's kind of sum up basically what the video is saying, right? So once upon a time, you have basically all kinds of chart, right? Okay, so when I was an engineer, back in those days, you basically put Pareto's of charts everywhere on the boards, on whiteboards, on blackboards and everything, and you try to draw the SPCs out everywhere, right? So this is where the world has started, in terms of trying to get all this information, but in order to really find that information that you need to decide a certain process improvement, you basically almost like finding a needle in a haystack, right? So with this innovations of digitalization, basically it has helped us to get to a point where we can make decisions faster, right? So we focus a lot on manufacturing, right? In semiconductor manufacturing, and that's also my topic today, right? It's about cost of ownership, right? Why? Because at the end of the day, as this, whether is it a Moore's law or productivity curve, it's about improving yield, it's about improving overall machine utilization, it's about reduce intervention of operators so that you reduce the mistakes or opportunity for error, right? And everybody is all looking at COO model, right? So how does digitalization help us to make those decisions to have better COO, right? And that's basically the crux of it, right? If your product you can be improved, if you get more traceable to find a problem, a fault, or something like that, then you are able to kind of see how you are able to make those decisions faster and productivity faster. And if you look at some of the manufacturing model that we have, right, so basically in back-end manufacturing, right, whether is it in back-end assembly for semiconductor, or you can go downstream to PCBA assembly and so forth, right? So we focus a lot about individual processes in the past, right? Looking at this piece of equipment, that piece of equipment, that piece of equipment, right? And we don't really look at the whole integrated approach. Why? Because machines are not connected in the past, right? So when things start to connect, then you can start sharing information. Then you can say, how does A impact B, and B impact C, and C impact A, or A goes back to D, and so forth, right? In the past, like I said, everybody was looking at a Pareto chart per machine, right, per process step, and it was very hard to put everything together, right? So why we need digitalization is really to bring everything together, so we can really look at things in a holistic approach and start looking at productivity improvements. How do I look at an entire line for example, right? It's not just this machine can go at thousands of speed, versus you have a bottleneck that can go only hundreds, right? How do you relieve those bottlenecks and so forth, right? So, and in this semiconductor model today, people want products faster, people want results faster, people want yield faster, quality faster, and so forth. So it's very important that all these links become the linkage towards the whole semiconductor for digitalization, right? So I want to focus a lot about how we collect, how we analyze. Basically, if you don't collect right, okay, if you don't analyze it correctly, you have a huge impact on not just the manufacturing, but also on individual and organization behavior, right? And here I'm going to be talking about some examples about why digitalization is so important in the new world, right? So this is a very simple, all right, flow of some of our steps towards evolving towards a smart machine. Everybody thinks of a smart machine as an autonomous, right? So it's the same in semiconductor back-end packaging, right? So this is an assembly equipment talking about, it's a wire bonder. Very basic fundamentals. People look at HVM, right? Okay, or are you stable? Your MTBA is what, your MTBF is what, what's your uptime? Those are all very fundamental per piece of equipment. But then if you look at things to look at a little bit broader perspective, then you start looking at how do I simplify the process? How do I have this process more closed loop so you can feedback to know what is wrong or what is right and how do we correct it? And then if you look at, equipment health monitoring, right? Can this system be broken down into subsystem health monitoring, right? In our examples could be, we call it a transducer, right? It could be a power supply. It could be something that's affecting basically the overall performance, right? And finally, you want to look at a whole fleet of equipment management. So our tools or our machines don't go by ones or twos, right? They go by fleet. And typically, if you go into any typical sets, you see rows and rows of it, right? Typically hundreds, 500s to even about 1,000, right? So if you imagine if you have an operator trying to tune every machine, if there's 1,000, how much information you need to process and how much things you need to dial the whole process together so that all equipment will maintain a certain performance. So let me just give you some examples, right? So this is a very simple framework of what it looks like, right? So you have an equipment, like I mentioned, we typically see thousands of wire bonders in OSATs, right? Because they're all wire bonding to high pin count type of applications in ICs and so forth, right? And those goes into 3C devices, right? And then you have hubs and switches in between, and of course we have KNX connector that connects that to a switch, and then the switch connects to a KNX server or an external server, like in any fab or any OSATs, they have an MES or some kind of database that they can host it, right? And of course, you can have a corporate database. Right? So these are all different schematics of it, but this is very, very typical. And as people go into huge fleet of equipment tool sets in terms of digitalization. So, but importantly now, everything is connected. Everything has a great network to be together, right? How do we analyze this? Right? Analytics becomes so important, right? Okay, so typical things. If you look at 3 examples I talk about, like Siri, right? Okay, if I want to go to a restaurant, or Google Map will remember the last location and tell you have 20 minutes to reach home, or 30 minutes to the restaurant, or 15 minutes to work. It's all self-predicting, because there's a lot of learning behind in terms of analyzing the behavior patterns of what we do. Okay, so the same thing for any machine, right? The machine has a certain patterns and behavior, right? As it continues to repeat and repeat and repeat, right? And because of that, you learn that behavior, and you're able to kind of do a little bit of prediction of what it can do better, or what's the next step, and so forth, right? So, of course, in Amazon and Netflix, we talk about, all kind of predictive marketing, right? Before you say, I want to buy, a bottle of beer or can of soda, it already tells you, because of your patterns, like 5 p.m. you pick up a beer or something like that. So let's talk about how this goes into the framework of AI and 4.0, Industry 4.0, right? So importantly, we talk about the collection of data. So data is very important, right? That you get from machine signals, you get from applications, you get from the bonder, and on the bonder or off the bonder measurements. And then you talk about algorithms, right? And all these are learning algorithms, statistical methods, all kinds of ways that we get those data into the machine to kind of learn it, right? And we talk about the achievement, right? The output of it, right? Can you be portable? Can you optimize it? Can you do closed loop monitoring? Can you do interdiction and so forth, right? So for the last 10 years, we've been doing a lot of this three focus, right? Collecting the right information data, having the right algorithms, and then having the right achievement, right? In terms of optimization and output, right? So we basically have an AI team, and basically the AI team looks at both engineering as well as manufacturing, right? Engineering because it develops the tool sets and so forth, and of course, how do we improve it in manufacturing, whether it is it in-house or externally, as we sell our machines or bonders out to a factory, right? So we basically, I think now AI is focused not just on internal, but it's also external. The same learning that we apply internally can also apply external. Learning applied external can be also used for internal, right? So that's kind of like AI team, right? So we create a suite of solutions here, right? Okay, and here this is like, we call smart process solutions, and these are like Pro Copper 7, PSP. These are all code names within our company in terms of those suite of solutions that we have, to learn how to do the loop, to learn how to do bonding better on copper, on Go better, and so forth, right? So you can see we have Pro Bump, Pro Hang, all kinds of process, right? And all this is about, AI learning, right? So you learn the process of years, you basically pour into a recipe. So today, if you open up the simple example that we always use, the microwave, right? You have 5 buttons, right? Okay, you can do preheat, you can go frozen, you can do what you call instant noodles, you can do things like that. because all these are pre-programmed. How do you program? Because it remembers, okay, the recipes and things that you learn for, right? And this is all the world about digitalization. Why? Because it's beneficial to customers, right? Productivity improvement, efficiency improvement, and then of course capabilities all step up, right? So this, you see this pyramid going up, right? About how we get basic data advancing all this capability to you reach AI or big data autonomous machines, right? And this is a history, right? We didn't start this AI roadmap yesterday, right? We started in 2010, right? And this is a course of history of where we went through in terms of bonders and then the bonding profile and so forth, looping and so forth, right? Intent is not to go into details, but just to show the history of where we came from in terms of automating things, digitalization things, right? So this is just an example of, look at the amount of wires that is overlapping, but none of the wires are actually touching each other, right? That's why we have the Pro Copper loop suite of tools that, again, that you can do offline, that you can kind of analyze this before you actually put the actual product in, right? This is all, again, enhancing the productivity, right? So if you actually have to do this wire placement and draw every wire cells, it's going to take you 3 months. Right? This suite of software will take you minutes to do it, right? So that's the advantages of about how we can do productivity, right? And because of this process here, very simple, example that we did recently, right? You show 112% of productivity improvement, right? Now, because we have the baseline, then we use a suite of tools on the Rapid Pro, and then we're able to see the improvements, right? First, we had a 7% on plug and play, then we go into we call a Pro Go tool suite, right? And then you see 112% improvements, right? So imagine all these improvements are coming because of digitalization. So just a few examples I want to show, right? So this is just an example of a small ball detection and a real process monitoring, which is called RPM. Basically, it captures an image, it analyzes pictures, it can classify the type of problems that you have. Here you have a small bond issue compared to a normal bond issue. And then basically, after you analyze it, then you say, oh, okay, something happened here, right? So we have the EFO, basically the height parameter setting was found to be incorrect, right? Just from analyzing the image and comparing image to a normal, and from the learning that we learned, we say, okay, this was a suspect case. That's why we analyze this to an EFO height parameter, right? So again, this is something that was a real life case, that how these tools can be used into real life production. So next thing is the ball size variation, right? Okay, here you have in ball bonding and wire bonding, they create a ball. Basically, the ball was smashed, right? And it was detected during the auto bonding, right? So an over squash ball compared to a normal bond. So similarly, the two sets was able to create that, right? And then use case number 3, right? Okay, in the area of pandemic, right? Everybody cannot go in, nobody it's supposed to go near a factory or fab, because they all need to have quarantine and so forth. So what do you do, right? So you imagine that you have a factory in Asia, like Taiwan or China, and then your support team are in Europe, right? So how are they going to fly? Nobody can fly these days in the pandemic, right? So you use the remote access in, right? So for example, here you have a web browser going through a recipe modules, and you have equipment connectors all the way to our bonders, right? So this is just an example of real life cases, especially in times of pandemic, right? Where you can actually not access the factory or the machines, on site. Here, we talk about advanced algorithms for fault detection, right? So, very famous name is called FDC, right? And this is all through kind of machine learning algorithm that we have developed in-house, okay? And then we're looking at the abnormal bonding conditions. Here, the examples here, we have contaminated devices, we have a cover gas that was off, a smash bond, and we compare basically, you can see the red line scores on the contamination versus, okay, the actual contamination. So the detection was very, very clear how close it is from the actual machine learning to the actual case, right? So again, it validates again some of the algorithms that we've done in FDC, again, going back to the whole world of AI, right? And then another example here, basically they have a cracked die, okay, the semiconductor that was cracked, okay, and during the bonding process. And then from a vision, you can actually look at the crack and non-crack, and then you apply a certain algorithms or neural networks here, right? So the neural network classifier basically look at the line segments, look at the chips along the line segment here, especially on the picture on the right, and basically can see how the AI was actually applied to it and able to classify a problem. Again, you're running thousands of machines, right? You are not able to go to every machine and intervene, and this is going to tell you that we have a problem here, or the cracked die You raise the alarm, you have a tower light that raise off red color, somebody looks at it, oh, you really have a crack die problem, take out the product and you start putting in continue on the process for the next thing or correct it. And then of course, those are all, we use in the OSATs, for example. Here, we apply the same concepts. And then one of my colleagues, PK, he presented this also in a recent SSIA forum, right? Looking at how we can look at the data, organize the data, digitize the data, capture the data, okay? And here he talked about how the suppliers, whether is it a contract manufacturer, can actually send the data over to us. We can look at those issues, send us email when there's a problem of some kind of notification, and then capturing and transferring those information over to the manufacturing in a real-time environment here, right? And then next you can see how it analyzes the data. Okay, remember the same set of network we talk about externally that we put our bonders in the OSAT. We use the same set of network into our own factory as we build up those bonders in manufacturing. And you can see, right? Okay, some of these connections are established and it can connect. And then we generate quality and output KPIs, right? Okay, how was the output? How was the quality? And quality has many measurements and so forth, right? And if you look at it, okay, then you can go down to drill down for specific situations where there was a defective part, and you drill down even further, right? And of course, most importantly is if you look at this waterfall chart, right? Basically, you can prioritize everything that is falling out, right? By classification of the different types of failures, and you can start, looking at those specific failures and start correcting those problems, right? So remember, I showed an earlier chart where I had all kinds of manual charts and we put, paste on the wall and so forth. Now you have this all automatic. You can look at the waterfall chart. You can analyze things that's happening, right? And you continue on this, and put all this into the cloud, and then you can look at, these are real data coming out, right, from our suppliers into our factory that shows you a problem, right? So this is the red colors in the below are actually showing real data of problems that we see. So we know this problem at the at the tip, where there is a problem, right? You correct it at the problem instead of further downstream. Then you realize you have to go backtrack all the way to the start of the process. So when also suppliers are giving information, qualitative information about their quality, we can feed that back into the manufacturer. And then of course, then you can see, we can plot all kinds of scatter plots, and then basically look at the triggering events. Okay, like I said, triggering events can look at an event base, some kind of things that trigger situations. And all these are actual live data that my colleague has presented before. And basically, this is the framework on how we have done it, right? You can see, on the left, basically, is all the data sources. Remember, I talked about collection, right? The collection of data is very important. And we talk about the visualization where things are shown in charts and graphs and so on, this parameterized. And you can start monitoring, then you can do some predictive analysis, right? And some of these collaborations, my colleagues also explain about how we have alliance with universities like NUS in terms of some of the predictive analysis work that we're doing now. So I think in summary, I want to say that digitalization is important. It's evolving. It's helping the semiconductor industries. But very important is that we have to really keep it simple, right? We have to find a problem, okay, that we want to solve, right? Not just try to do everything, right? Just find your problems and solve, figure out what is the thing that you're trying to solve, and then of course follow a new workflow, right? The new workflow here basically shows that in the past we collect a pile of data, right? Collect, keep collecting all information. Then we try to sieve through the information to find what we need to analyze to find the failure, right? But in the new world of doing things, we start from the end in mind, right? We look at what data you need to collect first. You look at what information you need to have insights, and then after that, you look at the critical decisions points that you want to make, right? So I want to summarize and give you an example of what we have done, right? Okay, and this is just using AR basically to improve on overall productivity. So basically, AI is task-based intelligence. A teacher is instructed to teach every operator how to think in terms of assembling a fixture, assembling a component, assembling something. Here we use AI. You can see the iPad on the left. You can see, how the 3D drawing is so being close on the actual event that's actually doing it, right? So with this, basically you eliminate, teachers to automate a way of teaching. And, we used to have 55 hours to bring up the software, right? So because of this, So again, this is a real life example. This is just from our factory floor. We will actually AR tool that we have. Just an actual iPad, right? Okay, so I think, like I said again, understand what the problem is, all right? Set the goals and KPI and cost and quality goals, whatever that is, create those immediately. We must always start with the end in mind, right? Don't do digitalization because everybody's doing it. And, it's cool. It's everybody wants to just join it now. But really start with the end in mind. What you're trying to solve, right? And of course, you have you bring in the SME, people, right? The subject matter experts, apply those value stream mapping to those pain points. Remember, you start from the pain point, you go down to the value stream mapping, then you can identify what is solving what problem, right? Then you look at a balanced approach, right? You go from a bottoms up, you go from top down, see how you can basically bring the two objectives closer together and analyze it, right? And of course, develop a systematic approach to data collection, right? You have all kinds of apps, you have ERP, you have MES, of course, KNS has its own systems. And of course, you need to organize, you need to structure, you need to centralize all these data sources to help you to do those techniques, right? And then before you start to scale, right, solve those 1-2 problems first, and you can start to, create, we call stepping stones to winning, right? Okay, so you can start building on some of those early successes, right? And as the ball keeps rolling, then you have a roadmap. You have a nice digital roadmap, okay, for digitalization, and then try to get engaged in management support. Management support is very important because that's also part of the digitalization framework of why every factory or every environment that this can help. In this case will be a semiconductor, right? So we truly believe, and we have embraced it in-house as well as our tool sets, as well as supporting our customers and clients worldwide. All right, thank you very much. I'm ready to take any questions.
Thank you, Chan Pin. We can see some questions coming in for you. So the first question from Terence from EDB, he asks, looks like if the material handling can be automated, the factory floor is lights out. What then is the comparative advantage of factory locations, efficiency of logistics, customs, MPI engineering capabilities? Can we bring back wire bonding to Singapore?
Wire bonding, it is in Singapore now. Okay. So, yeah, I think that this whole virtual fab is getting to be much more globalized, and with connectivity and 5G coming on soon. Speakers yesterday were talking about the rate of transfer of speeds is going to be incredible, right? So it's just like today, where we have virtual clouds, right? You don't know where actually your YouTube video is coming from. It'll be coming from different parts of the world, right? So I envision that as the 5G infrastructure is built and lights out factory becomes more and more automated, I believe factories can be built almost in any location, right? Provided you have the same processes and same workflows and so forth, right? So I think, whatever that I've been built on today, if we apply this in different, concepts of different manufacturing, yeah, you can have manufacturing in Singapore, you can have all different kinds of manufacturing in Singapore, because it's going to be virtual, right? Then we're looking at efficiencies of your AI tools, right? How efficient is it? How much you can improve, right? You have less reliance on, oh, my people cost is very expensive, right? You have less of that because a lot of things is going to be driven. In my video, I show you a dashboard of a remote control, right? Basically, everything can be operated in that location. And of course, I never review where the location of the video is made because it's immaterial. The fact that you can have an autopilot behind anywhere around the world to manage factories, I think that's going to be the vision of the world in terms of factory.
Understand. And second question, Jay from UCT, what type of vision system do you use to capture the bond quality?
We have our in-house, okay? In-house, because a lot of this was learned from our prior experiences, right? Okay, so we have this post-bond inspection, okay, PBI, okay, that's a tool that we use after it, okay? As you know, we have a lot of optics in our equipment, so those can be all basically available from our own user interface, right? So in short, yes, but of course, mapping and charting and all these things, wafer map, you can done through, a lot of tools out there, right? But in terms of visualizing and analyzing those type of failures from our bonding, it's mostly in-house.
Okay, due to time constraints, let's take in 2 more questions. Okay, is KNS looking into self-diagnostic capabilities on your tools and all your equipment being connected back to your factory to support a lights out model?
This is getting there, all right? In simple, it is getting there, okay?
Okay.
And then equipment monitoring, I mentioned in one of my slides. Okay, yes, there is already is in the roadmap, and we are increasing more and more. Okay, you can see this last box on the right hand side: total equipment management, predictive auto calibration, remote monitoring, product improvements. All this is getting to a point where, like I said, my dream is that an iPhone, you can actually control all your machines. Okay? That you can really look at the diagnostics on the phone, just like you're looking at your bank statements on online. Okay, that's the vision. Okay, as more and more things are becoming more available, and I can show you iPad, I show you things remotely can be done. Yes, I think the vision is getting there, and this is the vision of we call total equipment management, where you can manage everything remotely. Okay, or through some kind of diagnostics. Okay, on a laptop or desktop.
Understand. So here comes the last question, and also is the most voted questions here. The training through AR capability, is it an in-house developed one or external application source?
Okay, I'm going to ask you guys to call 1-800 number, and it's a hotline person to sell you. So no, okay. The AR tool today is available with many third party. What's important is that you have to apply the AR tool in-house into your environment, right? So those 3D drawings that you see, okay, on the iPad are actually CAD drawings from our actually tool sets, okay? So, so you need the input of those CAD from our, machine drawings, and you input into a tool, and the tool will basically help to, emulate, superimpose onto it. And then you have to develop the recipe, right? In the case of that will be training and operator assembly, 1, 2, 3, 4, 5. So you need to teach that software to say, step 1 is do what, step 2 is that. So there's a collaboration between the third-party software, in-house CAD models, integrating it, and then applying it to the real environment. So, but yeah, I'll be more than happy to take in more questions on that. There was a lot of queries on that about how we do it, but this is just not. And of course, if you are interested, one day when COVID is over, okay, when things are settled down, come to Serangoon, okay, back to Terrence's point, yes, it's in Singapore, okay? We can actually show live to you how we do the AR live in Singapore. Thank you.
Thank you, that will be good. Okay, thank you, Chan Pin. Due to the time constraints, I think we have to stop here for the questions. But Chan Pin, you can stay online to answer the questions by typing in the answers, or we can also get back to you on the unanswered questions and post it in our LinkedIn page. Thank you, Chan Pin.
Okay, all right, let me stop sharing then. Thank you.
Okay.